All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have a car is prevented from moving by pulling on a rope, which is wrapped 3 1/4 times around a tree. So our car is trying to go away. We're pulling back and trying to prevent it. If our coefficient of friction between the rope and the tree is 0.3, what's our force that we have to pull with to keep that car from going? If it's pulling with a force of 3,600 newtons. So we're approaching this as a belt friction problem. And we know our belt friction equation is that T2 equals T1 times E to the mu beta. T2 should be our tension in the direction of motion. So if everything were to start moving, which way are we going? T2 is the other direction then. E is a constant, Euler's number. You have an E button on your calculator. Mu is the coefficient of friction. We know it's 0.3. And beta is our contact angle in radians for us. Let's go ahead and try to find this. So we know if we started to set things up in here. Let's actually draw a real quick picture. So if I draw my stump on this, we're saying we're wrapping 3 1/4 times around this. Really, we could come in here and say one of my forces is going to go straight up, one's going to go a quarter turn the other direction in here. And as I set that up, I just need to establish which one is which, based on which way am I going. So if I say that car is pulling with 3,600 newtons, I know the other side of this is that force P that I'm resisting this with, P. And really, all I want to do is come in and say, if it moves, which way does it move? And I would say, if this car starts to move, it's going this direction. My motion is this way. So I'm going to label that in a quick picture. That's going to help us determine which way is T2, which way is T1. Our T2 is always that direction of motion. If we're moving towards 3,600, this is T2 for us. That opposite side then, P, is going to be our T1. T1 equals P. We can use those in our equations. The only other thing I need is beta. Beta should be, well, we know it's 3.25 is our contact angle, or revolutions. And I know that there are 2 pi radians per revolution. Let's write it out. 3.25 revolutions, or we'll call it revolutions, times 2 pi radians per revolution. Our revolutions cancel. Our beta angle is 3.25 times 2 pi, or this is 6.5 pi. Or we could factor that pi in and get some weird decimal number. But either way, it's totally fine. That gets us everything I need to really finish my problem. My T2, 3,600, equals T1, P, times E to the mu, our coefficient of friction was 0.3, to the 0.3, times beta, 6.5 pi. And I can solve that for P. My force here, P, is going to get us to 7.87 newtons. Or because no one really thinks in newtons ever, we're really saying this is about 800 pounds that car is trying to pull with. Because of the friction helping us out here, we only have to pull back with about 2 pounds to hold that car back. Friction is doing the bulk of the work. Now that's also ignoring things like, realistically, if that car is trying to go, it's impulsing as it pulls, not just one constant force in here. You're getting acceleration, that's going to change things up. But the general idea is going to be true force. If there's a constant force in here, this is the only force I need to resist that with. But hopefully this is a quick, easy video for us. If it was, hit those like and subscribe buttons. Stick around. Let's watch more videos. Get UNA with JJ.